This tutorial will give you examples that will help you to complete homework number 10. So the first box asks you to graph each equation on the set of axes below, to put arrows on each end, and label the line. So for number 1, the linear equation is y equals negative 1/3 x minus 5. Now remember, these two values mean different things. So the number circled in blue is the rate of change, or the slope, and the number circled in red is the y-intercept value. So the y-intercept is an actual point on the axis. So that means you have a 0 in the x position and this number in the y position. So you can graph the y-intercept of 0, negative 5 right here on the y-axis. From this point, you are going to travel along the rate of change, which for us is negative 1/3 so negative 5, and then from there we will rise negative 1, down 1, and run positive 3. Rise negative 1 and run positive 3. Now I don't have much room for many points, but all you need is 2 to make a line, so I could make my line here, but because I want my line to be very long and stretch from edge to edge of the graph, I'm going to reverse my negative 1/3 to 1/-3. These are the same fractions. Where the negative sign is, whether it's on the side, in the numerator, or in the denominator, doesn't matter, but you can only use the negative sign once. So the first time when I used it, I used the negative sign with the 1. That's what I did the first time. The second time I use it, I'm going to use the negative sign with a 3. So that means I'm going to rise positive 1, but I'm going to run 3 to the left, or negative 3. So rise 1, run negative 3. And now I can stretch from one edge of the graph all the way to the other and put arrows on both ends, and this says label the line. You label the line by writing the equation right alongside like this. Now, it kind of seems like a moot point when you only have one line on the graph, that it would obviously be y equals negative 1/3 x minus 5. But pretty soon we're going to start drawing two lines on the same graph. And when you do that, you need to specify which line is which. For question number 2, the rate of change here is just a negative sign. So that means it's an invisible 1/1. Now remember, when you have a negative sign, you can only use it once, either in the numerator or in the denominator. The y-intercept also happens to be negative 5. So I'm going to start on my y-axis at negative 5, and I'm going to travel using my rise and run here. My rise is the numerator, and my run is the denominator. So my rise is negative 1, so that means I'm going to go down 1 unit. And my run is positive 1, so down 1, right 1, down 1, right 1. Remember, you can put the negative sign in the numerator or put the negative sign in the denominator. If I put the negative in the denominator, I would rise positive 1, but run left. Up 1, left 1, 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 up 1, left 1. Now you don't have to draw all of these points if you have a straight edge ruler. I don't have a ruler for my computer, so I'm going to draw as many points as I can to get it perfectly straight. Put arrows on both ends and label the line y equals negative x minus 5. Now if you look at question number 3, the linear equation is y equals 2x. And that has one number, but it doesn't have a constant at the end. So if you're missing that b value, you fill it in with an invisible 0. So that means my first point is going to be at the origin. And from here, I'm going to rise 2, but since it's not a fraction, I fill in the denominator with a 1. So rise 2, run 1, up 2, right 1, up 2, over 1. Now remember, if you run out of space or you'd like to draw a longer line, you can reverse the signs. So instead of positive 2, I have a negative 2. But if I reverse the sign of the numerator, you also have to reverse the sign of the denominator. So positive 2 over 1 is the same as negative 2 over negative 1. So down 2, left 1, down 2, left 1, down 2, left 1. And now I have a perfectly straight line from edge to edge, arrows on both ends, and a label. And that's how you graph linear equations and label them. Don't forget, if you're missing a value, sometimes you fill it in with ones, and sometimes you fill it in with zeros. Coefficients can be invisible if they are the number 1. Constants can only be invisible if they are the number 0. Let's move on to the second box. Find the rate of change. When you have an equation, it must be in the form y equals mx plus b. When you have 2 points or a table, you have to use the delta y over delta x formula, which is y minus y over x minus x. So let's take a look at this first sentence. The y here is not by itself, so I need to circle and switch my coefficient term. So my y stays, but my 5x switches sides, so it switches signs. My 7 did not switch sides, it remains positive 7. So the coefficient of x is the rate of change, not the letter x, just the number. For number 5, I have 2 points, so I'm going to use my delta y over delta x formula. So I'm going to put them in a little mini table, and then I always circle my y's. So y minus y over x minus x. Now notice, my formula has a minus, and my 3 also has a negative sign. So I'm going to have 2 minuses in a row, which converts to a positive. 8 minus 7 is 1. 4 plus 3 is 7. So my rate of change is 1/7. Now, I can use this same formula for the table, or I can just find the pattern of the numbers. It looks like my y's are increasing by 3. So that's my numerator, because the pattern of the y's is the numerator. It looks like the pattern of my x's is that it is decreasing by 2. So that's my denominator. Now for question number 7, you have a graph. So you could actually write down these points and use this point formula up here. Or you can use the graph method, which is to count the rise and the run by checking your units. It looks like my units go by ones, so I can count by ones here. So I find 2 perfect corner points, so I'll pick these 2. And I count the rise. 1, 2. So my rise is 2, positive is up, and my run is 1, 2, 3. So that is my rate of change. Now if you had picked different points than me, like say these 2 here, and you counted your rise as 1, 2, 3, 4, and you counted your run as 1, 2, 3, 4, 5, 6, that would still be equivalent if you reduced it to 2/3. So this answer is correct, but this answer is better. Alright, for question number 8, I'm going to go back to my formula, y equals mx plus b. The number in the m position is the coefficient, or the rate of change, and this is not in y equals mx plus b form. So what I'm going to do is I'm going to circle and switch my 4x and rewrite the rest of my problem. Remember, circle it, switch the sign. And now I have to get y all by itself, so I'm going to divide by this -7 coefficient. And now my sentence is in slope-intercept form. Notice I did not divide 4 by 7 because it doesn't come out to be a whole number or an integer, so I'm leaving it in fraction form. But notice I did take my 2 negative signs here and simplify it to 1 positive sign. Positive 28 divided by -7 is -4, so my rate of change is the fraction 4/7. So for question number 9, I'm going to use my y minus y, so these are my y's, -7 minus 7, and these are my x's, 8 minus 6. So this is -14, and this is 2. -14 over 2 is the answer, but -7 is better. Okay, let's flip the paper over to the back side. Which function has the greatest rate of change? Function A, function B, or function C? This is a multiple choice question. So I have to choose which one has the greater slope or the greater rate of change. This is a graph, so I'm going to use my rise over run method. This is a table, so I'm going to use my delta y over delta x method. And this is an equation, so I'm looking for the coefficient of x. So let's see. For letter A, I'm going to find two perfect corner points. So it looks like this one, and this one, and this one, and this. Those are perfectly through the corner boxes. So let's see if it's constantly the same pattern. Up 2 over 1, up 2 over 1, up 2 over 1. That is constantly the same. So letter A has a slope or rate of change of 2. Now let's check the pattern here. Down 1, down 1, down 1. And let's check the pattern here. Up 3, up 3, up 3. So this has a rate of change of negative 1/3. And this has a rate of change of 2. So right now, A is in the lead because 2 is bigger than 1/3. And this one here has a coefficient of 6, so the rate of change will be 6. And 6 is greater than 2. Therefore, letter C has the greatest rate of change. So letter C has the greatest rate of change. So I'm going to be a little lazy here and abbreviate rate of change to ROC. All right, last box. Find the rate of change for the following data. So I have 2 points, and I always start with my y's. So 5 minus 5 over 7 minus 1 is 0 over 6. Now, even though this is correct, you must take a fraction with a 0 and go one step further. If the 0 is in the numerator, then the answer is 0. If the 0 is in the denominator, the answer is undefined. So our answer for letter number 11 is 0. Number 12, identify the rate of change in the following linear equation. Well, I can't tell you unless it's in this form. And this does not have a y by itself. So I'm going to do some mental math here. I'm going to divide every term by negative 5 and rewrite my sentence. And now I know the rate of change is negative 2. Which of the following is not written in slope-intercept form? Well, slope-intercept form is y equals mx plus b. Letter A, y equals mx plus b. Letter C, y equals mx plus b. Letter B, y equals 5 over x? No. That is not in slope-intercept form. And how about letter D? 5x plus... Nope, that's not either. You can't have x's and y's on the same side. You gotta have y by itself, and you gotta have x in the numerator, not in the denominator. So it looks like B and D are not written in slope-intercept form. All right, last 3 is mixed review. So to solve, you get x by itself. You should feel very comfortable solving equations by now. When you have variables on both sides, you subtract or add the whole variable term. 1r. And from now on, I'm going to leave this 1 off. Leave it invisible. Now for this one, I'm going to need a calculator. So let's see if I can open mine up here. See if I can find it. Here we go. All right. So 0.4 times x, well, that I don't need a calculator for. 0.4 times 20, let's see, 0.4 times 20 is 8. Bring down the minus 6, and over here I'm going to distribute just like I did over there. 0.2 times 6 is 1.2, and 0.2 times 20 is 4. These are like terms on the same side, so I'm going to combine them together to get a 2. But everything else will stay the same. I think I'm going to subtract 2 from both sides. And now this is the side that has too many terms, so I have to subtract 1.2x. Let's see what I get. 0.4 minus 1.2 gives me negative 0.8. And now from here, I need to divide by negative 0.08. I'm sorry, negative 0.8. 2 divided by 0.8 is negative 2.5. I hope that helped you to complete homework number 10.